Welcome back, student, to section 11.10 in Calculus 2. Before I start today's lesson here, in the third part where we discuss the Maclaurin series for the sine and the tan inverse, I did a mistake here, if you can see it, this one here. I wrote that the interval of convergence for the tan inverse is from negative infinity to infinity, and what I really need to say here is that this is wrong, and the correct one, or the correct exact answer, is the radius of convergence will be 1. And why I correct this one into 1? Because remember the way we get the tan inverse through this series, and we said if we do integration or differentiation, we keep the radius of convergence. Maybe the interval of convergence will be different, but the radius of convergence is still gonna be 1. So please correct this one in your note. And now, we'll do this question here. Now, if you look at this question, this seems to be a little bit familiar. Why? First of all, it's alternating. It has even powers and over even factorial. Alternating, even power, even factorial, this seems to be something we have seen it before. Now, can you recall what is it? It is, yes, exactly. It is the kind of the cosine. But in order to know its cosine of what, we need to write it down into the same format for the cosine. The cosine looks something like this. Alternating, even power, even factorial. Now, alternating, this is alternating. Even factorial, this is even factorial. What do you think we should write here inside the bracket? Yes, exactly. It is pi over 6. Now compare the white and the yellow. They are the same. Just we're rewriting them in a different way. So the final answer would be cosine pi over 6. Which is square root of a 3 over 2. Okay. Whatever this number is. Okay, so that's how we find. Sometimes we give you the series as plug-in numbers inside it, and this is how we get the final answer. Now, the next question seems to be a little bit also familiar with us. First of all, you can see it has odd numbers and odd powers. I think we have seen something like this when we have odd numbers and odd powers. And that's exactly what we have seen was the tan inverse, which is summation odd over odd. Now, all what we need to know is what are the numbers. Now, what is the number that is having the power is 1 over 2. So just 1 over 2 here. So in short, this will be tan inverse of 1 over 2. Just try to mimic the series according to what we have. Next question is f of x equal x cubed cosine of x squared. Now what we need is to find the 11th derivative at 0. So here we have two options. We have to go to the old school, finding the first derivative, second derivative, third derivative, fourth derivative, until we reach the 11th derivative, and good luck with this. That's what we will not do today. Or we can find something with the series. Now, what do I mean by something in the series? Now, this is f of x. And the general formula, the general one, is this is n 0 over n factorial x power 11. So what actually wants to find is, sorry, not 11, it's n. Now, if we want to find f of 11, okay, here we must have the 11. We must find x power 11. So let me write it down for you. We need to find the coefficient of x11. That's what we are going to find. So we need to find the coefficient of x power 11. So we have to go back to the left hand side and try to find what will be the coefficient of 11. Now, the left hand side is easy. It's x cube summation from n0 to infinity. It's alternating. It is even power over even factorial, and that is x squared, which is just x cube summation -1 to the n x 4n over 2n factorial. -1 to the n. Now take the x power 3 inside. We get 4n plus 3 over 2n factorial. Now, how do we get the 11th power? So this will be, if we expand it, will be something, something, something. I want x11. What will be the number in front of x11? To get x11, which n will give me x11? I think 2. So we have to substitute 2. So it gets -1 square over 4 factorial x11. That is the power of 11. And now this is exactly equal the 11th derivative at 0 over 11 factorial. This means the 11 power of 0 equal 11 factorial over 4 factorial, whatever this number is. And that's how we solve it. So mostly comparing the power of x, that will lead us to exactly what we need. Thank you very much for watching.